Hello, everyone. It's great that you guys are here to join us. This is the second In Conversation lecture of the semester for the Cooper Union's Irwin S. Channon School of Architecture. I'm Kevin Chow, an organizer for this lecture series, co-moderating with Marin Spire. So today's event will begin with two presentations from our invited guests, followed by a discussion. Questions from the audience are very much encouraged. Please leave them in the chat, and some will be selected for the discussion section. Today, we are delighted to finally have in conversation Will Shapiro and Farzin Lotfi-Jam. Will is the co-founder and CEO of Topos, a company dedicated to changing the way we understand location through the interconnected lenses of big data and artificial intelligence. He received his B.Arch from Cooper Union in 2013. Prior to studying architecture, he studied mathematics with a focus on algebraic topology at Brown University, Cambridge University, and the University of Chicago. At Brown, he discovered a relationship between the Fibonacci numbers and a set of continued fractions. The resulting paper was awarded the David Howell Premium for excellence in mathematics and natural philosophy by Brown University. While working with Cecil Balmond in London, he developed a suite of software tools for visualizing and producing novel geometries based on higher dimensional mathematics. More recently, he has been developing interdisciplinary approaches to understanding big data through innovations in machine learning, computer vision, natural language processing, geometry, topology, and statistics. Prior to founding Topos, Shapiro was head of research at Seed Scientific and head of research analytics at Spotify. Farzin is director of Farzin Farzin, a multidisciplinary design studio working across architecture, urbanism, computation, and media. He is faculty here at the Cooper Union and at Columbia University's Graduate School of Architecture, Planning, and Preservation, and is currently an M+ Design Trust Research Fellow. His practice investigates the history of computational paradigms and experiments in their contemporary application, from modeling the control matrices of smart cities to spatializing the cultural logics of social media. His individual and collaborative projects are research-based and multimediatic. His work has been selected by the Centre Pompidou and the Sharjah Art Foundation, and his research has been supported by the Graham Foundation, Academy Schloss Solitude, and the Shed, where he was an inaugural open call artist. He has been exhibited at Storefront for Art and Architecture, National Museum of 21st Century Art, the Venice Architectural Biennale, the Oslo Architecture Triennale, the Istanbul Design Biennial, the Seoul Architecture Biennial, the Sharjah Architecture Triennial, and elsewhere. His co-authored book, Modern Management Methods, Architecture, Historical Value, and the Electromagnetic Image, was recently published by Columbia University Press. And with that, let's start with Will.
Great. Well, thanks so much, Kevin and Marin, for inviting me and for your very lovely introduction. I'll go ahead and share my screen now. And let me just pull this up. Okay, is this everything cool? Yep, from
it's all
okay,
there.
Excellent. Okay, so today I'm going to talk about geospatial data and geospatial data science through a few different case studies. Kevin, thanks for the introduction. You kind of summed it up very well. My backgrounds are in mathematics and architecture and AI, and I've always been really passionate about interdisciplinary studies in general. So I decided to leave my role at Spotify and start Topos in 2017 to see if we could, me and my co-founder Mahir Yavuz were super passionate about cities and data, and we were really curious about whether we could expand the way that data was used to understand cities. And go beyond some of the standard metrics of place, like the census or foot traffic or vehicle traffic, things that people generally point to that don't really give a kind of a holistic understanding of what makes Williamsburg different from Murray Hill, even though they might be kind of similar from a demographic perspective, or why certain neighborhoods in New York City are maybe much more similar to neighborhoods in LA than they are to neighborhoods in Albany, despite being totally separated geographically. So we wanted to really radically expand the lens of data that was being used to understand place and bring in alternative data sets, things like the density of third wave coffee shops or tax returns or street grids, things that were harder to work with and required substantial transformation, but we felt could be really powerful in giving deeper insight into the culture of a place. And throughout this process, we've been publishing a lot of our findings. So I'm going to take you through a few of those to kind of illustrate the kind of ways that we've been thinking about data and AI in relation to cities. So one of these projects was called 5 Boroughs for the 21st Century. And it asked this question: what happens if we get rid of the definition of the boroughs, which at this point are over 100-year-old, and kind of remap the city to reflect the realities of 2020. And just for a little background on the boroughs, they were defined in 1898. They still are and were at that time all separated by water, except for Brooklyn and Queens. But that was a much bigger deal when they were defined, because there were like 2 bridges. And since the time that they were defined, there have been over 2,000 bridges and tunnels connecting them in different ways, not to mention the subway, which is the biggest transit system in the Western world. So there's kind of a radical new connectivity between the boroughs. And we thought, let's use data to group neighborhoods rather than this kind of antiquated definition of the boroughs. So what we did is we took all of our different data points, the tax returns and coffee shops and street grids and what kind of music people like. And we used all of that to redefine the kind of connection of the boroughs. So what you're seeing here are kind of all of those dimensions that powered this new clustering. And one of the key things that we needed to do was deal with all the correlated variables. So things like the density of vegetarian restaurants and the density of vegan restaurants tend to be highly correlated. So in order to kind of work with all of this data, we first needed to reduce the dimensions. And then we created a kind of data-driven clustering of our new boroughs for the 21st century. So what you're seeing here are the kind of 5 boroughs for the 21st century. And on the right is a 3D visualization of them as data points. So you can see that they're kind of within this cube, they're very close together. And then on the left, you see the kind of traditional mapping of New York City with these new boroughs. And this is kind of like the fully transformed view. And we were super excited about this. Largely, the kind of old definitions of the boroughs were erased, although you still see Lower Manhattan kind of groups together. But now Upper Manhattan is much more similar to commuter Brooklyn than it is to Lower Manhattan. So this was kind of an approach that took in a really large amount of data, a very wide range of data sources. But we also said, what's interesting is pizza, because what's more New York than pizza? How do we understand the city through pizza? Like I bet there's a lot there. So this was a project called On Pizza Vectors and Topping Hyperspace. And it may sound pretty crazy, but it was actually very much inspired by the work of Walter Benjamin. So Benjamin took a historical view of Paris in the 19th century, and he went kind of way beyond the traditional historian's view of historical events and politics, and said, what if we look at malls, right, which are the arcades, which this became the Arcades Project. Let's look at malls and mirrors and prostitution and gambling and poetry as a lens to understand the city. So we find pizza very poetic and also very interesting. And we said, okay, let's create pizza vectors, and let's look at the city through pizza. So just to take one example of how pizza can be interesting, what you see here is mappings of the concentration of people in the daytime and in the nighttime in New York City. And juxtaposed with that, we have dollar slice locations. And you can see that the dollar slice locations kind of closely outline the border of the nighttime population. And the daytime population leaves a lot of them out. So already there's a kind of index that dollar slices create in relation to understanding the population of the city. So what is a pizza vector? This is something that actually takes a lot of time to construct. It's not something that's widely available. But what you're seeing here on the left is that for each zip code, we have constructed this pizza vector, and it kind of describes the ways that pizzas are topped and what they're accompanied by. So you see things like whether they have truffles or not, whether you can get pancetta as a topping, whether there's a dollar slice available, whether they sell calzones, whether they sell broccoli rabe, right? And even the ways that toppings are named, right? Buffalo mozzarella is, related to mozzarella, but also means something different. So we constructed these vectors, and then we said, okay, what can we do with these pizza vectors? Well, to start with, we can create 5 boroughs of pizza, right? So playing the same game, let's divide the city now just based solely on pizza. And so this is a mapping of our 5 boroughs of pizza. So we were excited about it. We thought, this is great that basically Manhattan and kind of gentrified Brooklyn are one group. They have pretty, that there's something there beyond just the way that their slices are topped that reflects an interesting reality. But we also wanted to go a little bit deeper because that cluster, the red cluster is so big. So then we kind of played the game again and subdivided the red cluster. And this is where things got really, really interesting. So one of the groupings that emerged here is this orange cluster, which is essentially hipster Brooklyn. But what was even more exciting about it is, it had parts of Greenpoint and Williamsburg and Bed-Stuy, but also you see it goes into Ridgewood. So this is kind of reflecting this reality that, Ridgewood has essentially become an extension of Bushwick. And again, kind of erasing these boundaries of the boroughs. You also see that the Upper East Side, the Upper West Side, and Park Slope all group into the same cluster. So that was super interesting, as those are kind of some of the most affluent, family-oriented neighborhoods in the city that are all connected by the ways that pizzas are topped. So just as a kind of contrast, this is a very different view of hipster Brooklyn, kind of similar outline, but this is based purely on tax returns. So what we're looking at here are the 5-year change in people who file over 200K. So this is the highest tax bracket. And what you see is essentially the impact of the L train in New York. So Bushwick, Williamsburg, Bed-Stuy, all of these neighborhoods have seen the greatest influx of high earners over the past 5 years. So shifting gears a little bit, I'm going to talk about the COVID-19 compiler that we built. So at the beginning of the pandemic, we realized that we were all New Yorkers, and we're totally freaked out about, of course, as everyone was, COVID. And at the beginning, it was actually really hard to get an accurate, up-to-date picture of the spread of COVID. So there was the New York Times and Johns Hopkins, but none of them had a complete view. So the first thing we did was we built a compiler to bring in the most up-to-date data across the country. And we also realized that we had a lot of relevant geospatial variables that we had already been studying that were very much related to COVID, since it's so much about the way that we live together. So you can see here two of the features that we had been looking at. One was the density of buildings with over 50 units in them on the left, and then on the right, the percentage of people who take public transit. And while the variables have changed dramatically over time and continue to change, there's always something that's pretty interesting to look at that we had already had kind of in the back end. So to take, again, tax returns in New York, where you can get COVID at the zip code level, COVID data, if you live in a neighborhood that makes less than 100K on average, as measured by tax returns, you're more than twice as likely to have COVID than if you don't. So that's a pretty like staggering statistic. And in general, you know, tax returns are super interesting in trying to understand how it's spread, because they give a much more granular and detailed understanding of the economy of neighborhoods. Another thing that we've spent a lot of time working on is thinking about how to disaggregate data. So COVID data is generally only available at the county level, and counties can be enormous. So trying to understand things like the average distance that someone has to drive to get to a hospital in relation to the density of COVID cases is actually really important, and has been super relevant for some of the organizations that we've worked with in mapping COVID. So what you see on the right, on the top, is a kind of random sampling of a county just based on choosing random lat longs. And at the bottom is a population weighted sampling. So what we did is we looked at the population within this county, and then we, again, are randomly choosing points, but they're weighted by the density of the population. So that's really, really useful in understanding like where, for example, mobile healthcare work should be done. If there's a lot of high density of COVID cases that are all very far away from a hospital. And that's also what this 3D visualization is showing here, is disaggregated COVID data. So rather than mapping things by county, what we're doing here is looking at the density of COVID cases. And this is a little out of date at this point. There's a lot more in Iowa and South Dakota and North Dakota and Nebraska, but it's showing how disaggregation gives a kind of much more powerful view of where it is most highly concentrated. So if anyone wants to explore this further, covid19.topos.com is a publicly available resource. There's quite a bit there, including a whole section on insights, which tracks the various findings we've had in relation to COVID data and our other kind of geospatial variables. So I encourage you to take a look at that, and thank you so much. Okay.
Thank you, Will. That's great. And I guess we'll just move straight to Farzin's presentation.
Hi, everyone. Hi, Will. Thanks so much for that. That was amazing. Kevin and Maren and everyone else, thank you for the invite. Let me share my screen. Can you see that?
Yes, we can.
Yes.
All right, give me 1 second. I'm going to see your faces. I'm going to move it on my other monitor so I can tell if this is doing well or if I'm totally bombing the talk. Hi, everyone. As Kevin mentioned, my name is Farzin Lotfi-Jam. I have a small practice called Farzin Farzin, or Farzin Farzin, that does kind of research, and we're looking at cities and computation and new spatial media. And so my practice and academic research examine how new media, network infrastructures, and technological ideologies inflect the politics of architecture in the city. And so through my practice, I've developed an applied research methodology where I actively theorize the implications of technology through critical form making. So this might be like a jam-packed, intense lecture. I apologize. 15 minutes. Will was 15 minutes on the dot. I might be a little over, or I might be very fast. It's going to be a little experiment because I'm trying to weave some of the work I've been doing with some of the research we've been doing. And so hopefully that kind of works out. And so today I will present recent research and projects that use new spatial media to visualize and simulate how algorithms, models, and notions of real-time govern urban life. I'll be looking at the history of real-time computational systems and infrastructures, and how complex environments, inhabitants, and their behaviors and relations have been theorized, virtualized, and modeled through digital simulations in a sort of in both military and commercial industries in a field of study that's sometimes been referred to as the military entertainment complex. And then want to look at how this has all been converging in the last 2 decades on the city with the emergence of what myself and my collaborator, Mark Wasuda, are calling an emerging computational urbanism. And so I'll talk about a collaborative research project we've been working on that looks into 2 smart cities and looks at how cities and their residents are being modeled as information, and how as subjects of the city they have habituated to a computational logic in what we're calling a computational governmentality. And then, maybe just to kind of open up the conversation, we can kind of reflect on potentially what this all means for the fields of digital studies, architecture, and urbanism. But I want to begin with these 2 recent forms of media. They both show the movement of bodies, but in different ways. On the left is a recent data-driven narration of the coronavirus from the New York Times. The story consists of analysis and narration of cell phone data that informs a computer simulation of hundreds of millions of people's movement. To the right, we have the trailer for Humanity, a soon-to-be-released PlayStation 4 game by Enhance and THA, where population management has truly become entertainment. I'm interested in these 2 media because they demonstrate 2 historically distinct techniques for modeling and simulating population behavior. One driven by statistical information and the other by theories of human behavior. And what this shows is how modeling algorithms are able to track subjects and use this data to model behavior, thus deploying anticipation as a technique to shape both subjects and territories. This anticipatory logic is what I'm examining in my current work. And so I thought it would be good to kind of talk about some of the things we've been doing at Cooper over the last year that some of you actually have been involved in. And we've been working on a project called Real Time, that this is the sort of animated GIF board that was designed by MTWTF. And it's a research and pedagogical project I've been conducting with Greg Schleusner, who's the Director of Innovation at HOK and student researchers here at Cooper Union. It's work we've been doing after we received an Epic Mega Grant from Epic Games, the makers of Fortnite, to use their software, the Unreal Gaming Engine, to think through architecture, curriculum, and tools. And so it sort of was all, in the genre of COVID cancelled events. It was all concluding in a symposium in April that's been postponed, and we're also staging an exhibition in Houghton. And so during this research, we've been really kind of like thinking about how the city itself is simulated and virtualized through different algorithms. And in a sense, we've been trying to produce simulations of simulations using gaming engine techniques. And so we've been kind of actively trying to analyze and theorize something while we're working through it. When we first started to work on this project, we were kind of interested in how Epic was starting to market and promote their product to the architecture, engineering, construction industry. And we're kind of interested in the sort of recurrence of this buzzword real time that's kind of been around since the start of computation in some way. So we're in Epic's kind of marketing their tool to us as a kind of a new sort of real-time 3D visualization paradigm, something that will allow for more flexibility and efficiency that is going to have great impact for architects. And so, the tyranny of the endlessly spiraling V-Ray bucket will go the same way as the scanline event horizon. And so we thought that this term real-time and the paradigm of real-time computation, visualization, interaction, and virtual experiences could address some additional concerns outside of just architectural visualization. And so we were interested in how this term first came into play with real-time computation in the post-war with projects like this, the semi-automatic ground environment that was produced in around 1958 by the US military. And so the SAGE, as is commonly known, was a system of large computers and associated networking equipment that coordinated data from many radar sites and processed it to produce a single unified image of the airspace over a wide area. So it's a large kind of network of towers, radar stations, massive sort of architectural, and physical sort of architectural spaces, and semi-automatic fleet of aircraft. And so, and this is kind of giving a sense of the large scale sort of continental saturation of all of that network. And so Epic's real-time platform is shaped by this example and this moment when the formation of real-time electronic computation first came into being through Cold War demands for centralized command and control over vast territories in a modular, flexible, efficient manner. And so for our project, we also wanted to ask, what does it mean that our profession, our design tools, and our metrics for productivity is shaped by this Cold War logic? But we were also interested in, other kind of global media events, let's say, where digital media experiences, virtual simulations start to confront the economies of liveness, like this moment when 10 million people watch Marshmello, your favorite EDM DJ, play a live concert within Epic's Fortnite platform. And so the economies around liveness and the virtualization of entertainment was also something we were kind of trying to grapple with in our project. And the sound for this is just like phenomenal. So if you haven't seen this, you should go back and see it. Or how the design, we're also interested in how the design and planning of cities are now starting to come under a real-time procedural modeling paradigm with a level of detailed world generation logic that is all too familiar to gaming engine enthusiasts. And so the way we framed the grant and the proposal and the project was that we were somehow sitting between industry and academia, and both Greg and I operate in both fluidly, but somehow we were producing a project that was like looking at the tensions and interests of all those. And so we were really thinking about how these tools of entertainment production are now becoming tools of design production, but they're also used to produce digital platforms that manage cities, and they're informed by military history. So that was kind of like, the big sort of umbrella of everything. And this is coming out of a series of seminars and that I've been teaching with Greg at the Cooper Union and at Columbia University. And so this is some student work that's coming out of this. This is probably some work familiar to you, Maren, from your sort of first class. And so we're kind of like really looking at how we could use a gaming engine to do information-driven simulations, interfaces, visualizations, sort of non-linear narratives, new sort of, this is also a series of students from Cooper that you probably know, non-linear narratives, or rethinking what a data set might be, or rethinking what a map of the city might be. And in this case, this is students from Cooper who've gone and 3D scanned different waste management systems within New York, or kind of thinking about I guess, yeah, social life mediated by artificial intelligence. And so the exhibition itself is a real-time system, and this is the plan of it. It will track and transform and immerse participants in the algorithmic narratives that are shaping the future of our cities. And so here's where I'm going to try to bring in some of my work as I'm talking about my research. This all comes out of a long engagement with the codes and conventions of digitally mediated domesticity that I've been working and thinking about, what constitutes urban intelligence here, social media, and sort of the norms and the behaviors that it's been producing. This is a project that was kind of looking at that.
Hello, and welcome back to this series, which is about how to make a paperweight.
And so shout out to Michael Young, Cooper faculty in the bottom left here. Your Cribs combines the culture surrounding YouTube videos in the early 2000s reality television program MTV Cribs, which features tours of celebrity homes. Like Cribs, we broadcasted a selection of domestic spaces by adapting the conventions of YouTube genres that inadvertently expose private interiors to the public sphere. And so if in this case, we were asking how does YouTube and other digital platforms frame domesticity? In our exhibition here, we're thinking about how different algorithmic propositions for the future of cities, framing our understanding of city. And so in the exhibition, there's 4 chroma key rooms. Each one is modeling a different type of future simulation. So we're looking at how different technology companies are thinking about optimizing domesticity through new products, or how vast sort of climatic potential climatic threats are being responded to through infrastructure, or the saturation of the street with new management technologies, or the creation of a new infrastructural territory, sometimes referred to as the drone zone. And so some just images of the exhibition. The idea is that you would go in, and in each room, you would have an interactive tablet that would allow you to interact with the live simulator, and then you would be chroma keyed into the actual simulation that you're creating, and that would be what's displayed on the monitors in real time on the left. And so, just thinking about all the sort of scenario modeling that we're doing, and we're starting to use agent modeling, which is something I'm going to kind of talk about a little bit in a second, but taking protocolizing all these different sort of propositions for the city and turning that into a set of relational decisions that we could then simulate using the artificial intelligence capabilities within the Unreal Engine. And so this is work by Jesse Bassett and Kiching Wu, where they're kind of starting to use GIS-informed data sets from New York City to model their scenarios, and so early tests of thinking about how potential pedestrians could interact with these streets. And this is a project, these are early tests from Austin McInnes, where he's flying a drone around Central Park and starting to think about this as a potential delivery logistics system. Here we're doing sort of dynamic 3D path finding with a sort of Amazon drone that's delivering chairs not so well. And so, and this project by Tasha and Max, where they're kind of starting to model what a kind of future domestic assistant might look like. And so for us, these like scenarios informed by actual propositions for the future of the city in some way. And it was really important for us that the student projects would start to use those very same tools to physicalize what that might look like. And so to play out those different narratives. And so it's all driven by a behavior tree that looks like this, and using agent modeling. And so the reason why we're using agent modeling, our methodology is to somehow do it the way we're looking at it, is that this is the method that's been used by engineers, by planners, by technologists to model human behavior. And so Uber uses it for predictive modeling of surge pricing scenarios. Security forces use it for simulation of crowds. Traffic engineers use it to ascertain the flow of vehicles, and Google offshoot companies are using it to model resident behaviors. If I get a chance to show that, I will. And so this is some of the different ways that sort of decision flow can be visualized, and some of the different kind of applications of agent modeling, and thinking about it in a sort of a kind of building context. Famously within sort of the animation industry, the kind of first complex, the first sort of way of animating agents is a sort of algorithm that was developed by Craig Reynolds in 1986, his Boyd's algorithm, where emergent complex global behavior would kind of come out of the multiplication of 3 simple rules at the local level. And so if we revisit humanity now, we understand that the decision-making tree driving its behavior is actually informed by this agent modeling paradigm, and by this theorization that human behavior can be modeled as a set of discrete local decisions that are then multiplied at a sort of global scale to produce a complex population behavior. And so I don't know how much, we're kind of at 15 minutes. I can sort of stop here, Kevin. I can keep going. There's a bunch more stuff. What do you want?
Let's do a little bit more. I want to see the serious games.
Okay. So agent modeling also has a historical connection to military use. It's been used in digital simulation to model friendly and enemy artificial participants. with games like this, where the military is using world building tools, game recording, behavior scripting, player and team stats to model, do sort of theaters of war and learning and training exercises. And there's a kind of like a very interesting sort of prehistory to military video games. The mathematical modeling and simulation of conflict using computers can be found in how this abstraction and probabilistic modeling of conflict was first developed in war board games for commercial uses. So this is Tactic 2, it's the first time that combat was sort of abstracted into this map, that each square had different possibilities and scenarios. And so this system that was developed by Avalon Hill and used to think about potential new conflicts, but to also model historical conflicts. And so obviously this was a board game that you would actually play it out over the mail with like somebody else, and you would send your moves to someone, and then you would kind of like move on the board. And so these are kind of like the first systems where in actually a commercial context, a system's being developed to make combat quantified and computable in some way. And this is the emergence of the first hexagonal map that comes back into the military and is used within the military to also model terrains, but also I'm sure you've seen versions of this. And so, just tracking that hexagonal grid and where that allows for an omnidirectional movement within each grid. And there's a kind of like amazing, just like vast production of a cultural imaginary coming out of some of the publications that Avalon Hill was producing, where there was kind of like monthly, The General was a magazine that kind of created this culture of gaming. And so, this then comes back into the military. So this system that was designed for commercial board games comes into the military in this moment where they start to validate this model against historical data, using it to produce a Falkland Islands war games. And so you can kind of like look through this where the military starts to use all this information that they have from a historical conflict to reconstruct that and to test to see if the decision making and if the sort of simulation of that conflict is correct within that system. And so, this all kind of comes to fore with more recent examples like this, where the American Army produced this game, Virtual Heroes. There was a kind of a massively successful recruitment tool. And so up till now, I've shown how technologies that were invented for military use use real-time computation, sensing, command and control, and how they made their way into entertainment platforms and the design of cities. I've also shown you partially how the opposite is true, how social cultures around gaming have informed military practices. And what this means is that these real-time technologies have become the interface through which violence is abstracted, normalized, and performed. And so, I'll kind of like leave it there. But yeah, maybe like one place that I could kind of hint towards is where this has been converging in maybe the last 10 years is on the city, with the emergence of the smart city, and with the different ways now the cities themselves are starting to have instruments called digital twins, where real-time data is actually coming in from physical sensors in the city, and it's informing a virtual simulation and a virtual visualization of the city. And so all of this is kind of things that we've been sort of teasing out and working on in this in progress research. Thank you.
Thank you, Farzin. For both of you, Will and Farzin, that's a fantastic body, a wide breadth of speculative work that you guys have shown to us today. Thank you for being so generous about that. Now I want to, since we have maybe 50 minutes or 45 minutes more like, I want to cut straight to it basically. So I'll get into the questions. And I want to tag on to what Farzin had just mentioned at the end, kind of the physicalization of that whole culture of data and the whole aesthetics of data, physicalizing in the built environment, like in the smart cities. So I think there's always like an issue in anything that is parametric or algorithmic about the level of determinism inherent in establishing parameters, right? So somebody else said it better, the anthropologist Shannon Mattern, she wrote that the data we generate based on determinist assumptions and imperfect methodologies could end up shaping populations and building worlds in their own image. So how do we avoid that? How do we embrace what smart cities can provide, while avoiding the determinism that can happen with imperfect methodologies. That's to either of you.
Will, I was just recovering from talking. You might have to start it up.
Yeah, I mean, I think that, you know, this is not something I know a ton about, but my sense is that, you know, there's a lot of decisions in terms of what the data is that's simulated, and there's a lot that's left out. So I think that's, you know, like when I think about what I've tried to do is really like say many different things need to be taken into consideration, not just, for example, population density as it changes throughout the time of day, which I can, you know, imagine being one of the critical resources, or like in the case of Sidewalk Labs simulation tools, there's a very deliberate set of like 7 variables that kind of dictate the way that their designs, their generative designs are optimized. So I think that what's challenging is landing on those 7 variables, because at this stage they need to be limited in some way, and thinking about what's being left out.
If I could tack on like a quick follow-up, you said that at this stage they have to be limited. Is there a stage in which they approach like infinity in terms of the parameters considered?
Well, I guess it's kind of like that ties into like how they're going to be used, right? Like already, like with those generative tools for, say, urban design, you know, I think that like, you know, for example, like Sidewalk's tool is not prescriptive. It's saying, you know, here is a set of outputs, and you can optimize against these different variables. I think that as that number grows larger, it also becomes increasingly difficult to make any decisions because there's just more variables that you're optimizing for. So I think that the problem with having that approach infinity is it makes selection of any choice impossible, because there's just like, and the combinatorics produces an endless number of variations for what a place could look like. And, you know, that becomes like, if a designer is involved, which I strongly think should still be the case, then that becomes like a cognition issue where there's no way that someone could possibly think through all the different permutations that are produced. I mean, I also am a strong believer, just like from a design point of view, in the happy accident, and like what is accidental, and like why the West Village is on a diagonal to the Manhattan grid, and like how amazing that is, the labyrinth that emerges when those two grids collide. And I think all of the kind of interstitial magic that happens in cities as they emerge over time, I question how that would ever be included into an optimization algorithm.
Yeah, I mean, if I can ask one more question, I think the kind of happy accidents are absolutely important, but I guess I have a question a little bit more about kind of threshold of what we consider to be data. I mean, starting in Farzin's presentation, or it's a totally kind of military lens of what data is. It's a geographic question. And then going all the way to your project, the pizza one in particular, where, you know, toppings of pizza is linked to home values. So the kind of standard of data has continued to expand. And I guess I wonder, do you see the definition of data continuing to expand? And if you do, what's kind of the next frontier of data? Or do you see there be a possible refinement of what we consider data to be?
Yeah, I mean, I think that it's, you know, I think there's a tacit assumption that data is something that exists, right? But something that I've spent a lot of time in thinking through, both in music and with Topos, is the ways that you measure things, because there's nothing that's taken for granted. And when I, I always think, when I think about, like, for example, like AI generated art, I always go to the worst Beatles song I've ever heard, which was generated by an algorithm. And I think that there's a very, very long way to go there. But a lot of it is about how the input data is constructed. There's this really, really critical step, which is making data features. And this is not something that's given, right? People think, oh, there's just the data, right? But actually constructing features that are useful and interesting is the work, right? With the pizza article, we were going and scraping Yelp and Seamless and, spent, figuring out whether a place had scamorza as a topping is actually like took hours, right? So it's kind of like a big part of it is the lens. And I think that, in terms of like AI generated architecture, I think it's very, very complicated. Like to actually define something that's like a structural element and what it does and how it performs within a building is an extremely like non-trivial problem, right? So if you say, okay, architectural generation is just based purely on taking images of buildings, that's very, very different than saying it's based on constructing data features around structural elements that can then produce a form. So I think it's a really non-arbitrary and a very creative decision to say that it can become an interesting and useful data feature. I think, yeah, I mean, like for me, what is really exciting are the questions that are kind of impossible. So like trying to understand, why, why certain cities are different. Like why is New York the way it is? Why is Paris the way it is? How are they different? It's impossible, right? Like there's a million variables. Trying to understand music is similar, right? And yet it's interesting and exciting to attempt to model and attempt to create the features that capture the magic of something.
When you say it's, oh, sorry, Farzin, go ahead.
No. I just thought like that was like an incredible presentation, Will, and to try to like maybe connect things a little bit more. I think Sidewalk Labs seems like a really good connection, right? And I think, because we sort of all know they're an Alphabet, Google sort of offshoot, right? And a kind of a recent tech firm that's an offshoot of Sidewalk Labs that's recently come out is Replica, who are a company that are producing virtual populations, right? So they're kind of offering urban planners a service where population simulation at a sort of, at not at a census tract level, but at a domestic residence level is possible. And so you can play out and you can simulate all sorts of different scenarios and see how residents of a city might what decisions they'll make if a certain type of, traffic infrastructure is going to come in, or a certain type of event occurs, or and so it's kind of like a little tricky how they're doing that, because in order to get that, the way they calibrating their synthetic populations is through anonymized cell phone data that's coming from who knows where. But if you kind of follow the thread of ownership, there's clearly like a lot of sort of speculation around where Google kind of enters the picture. And so it's an interesting one, right? And like the fact that you are able to simulate decision making of an entire population to that sort of granular level of resolution. And so I think like you can definitely ask a lot of very interesting questions there, and you can definitely look at lots of different permutations of possible futures and start to potentially respond to it. But maybe kind of like what I was trying to illustrate through some of my work is just thinking about that's not some sort of apolitical process, right? That this thing that is potentially offered as a utility or as a tool to city planners, everything about how that data itself has been extracted, has been aggregated, all of that has a kind of a political project that has privileged a certain model of I don't know, the value of the data I'm making as a user of the city, and that I don't get to sort of know that value in some way. And so I don't know, like I kind of want to just, like there's this sort of the reeve of, there's the fever of what you can do with information and the possibilities of what you can model and the questions that you can ask. But there's also, yeah, like if I had to ask what made New York the way it did or what made Paris the way it did, I think like thinking that through sort of political questions and thinking about, I don't know, the sort of democratic processes or some of the other decision makings that did that as well. So I'm kind of like really curious how all of that comes into, I don't know, like some of the modeling questions and yeah, like every time I sort of show projects around smart cities or for analyzing, we're showing some of that research, everyone's always asking, are they good or are they bad? You know, like everyone kind of wants a really simple, is this utopia? Is this dystopia? Right? And so like those binaries around like how we evaluate, you know, and you kind of say, well, it's complex, like there's utility, that it's great. But maybe what I was trying to sort of show in some of my work is the rhetoric around optimization and efficiency and flexibility. That's the rhetoric by which we're now shaping our cities. And then these technologies that have been produced out of that, that have been shaped by that, that's the way, you know, we manage urban environments now. And so maybe that rhetoric is something we want to kind of question and confront, and those values that it engenders as well.
Yeah, well, first of all, I thank you for your presentation. It was really provocative to me and really exciting. And, you know, I think one thing I haven't really thought that much about or worked with is simulation. So that's kind of a new space for me. And, you know, I think what's interesting, you know, the replica example, that's what it's called, replica? Like that's one of like—
It used to be called doppelganger.
Doppelganger.
But then that got some bad press, so they rebranded.
I mean, that kind of data is like, there is a lot of different companies that do that. So for example, like Foursquare, which people might remember, like their core business now is selling data about where people are. So because, you know, people don't really use Foursquare anymore, but Foursquare built an SDK, which all these other app companies use. And that allows them to understand really granularly where populations are. So there's a bunch of different companies that do that. And I think, you know, one of the things that's interesting is that that's really different in Europe than it is in the US, right? Because of PII rules and GDPR. Like there's pretty radical differences between the ways that populations are measured in those two places. I mean, you know, I guess I'm like, I think that, you know, one of the core challenges with any of these data sources in relation to optimization is just like, do you, you know, I don't like Sidewalk, right, is not saying use this tool to design your city. They're saying use these inputs as possible parameters for the way that you think about the relationship between population density and daylight and foot traffic and accessibility. Like it's a complex optimization problem to balance all of those things by just looking at without any kind of data, right? So I think part of the question becomes like, what's useful as an input for design, and what's overwhelming and what's prescriptive. like another example is like envelope, right? Which is doing really smart things with FAR and sunlight, and that's like a complex optimization problem. And the question is like, is that prescriptive? Does it lead to an optimized world without humanity, or can it become a useful input in thinking through design?
Yeah, like I can respond and keep talking, but I don't know what's the format. Like, do you want to? I have, yeah, like I'll respond. Yeah, well, the first question is sidewalk. What's sidewalk labs, right? And what's the city, and how does sidewalk labs define the city? And in a sense, sidewalk labs, you might think sidewalk labs defines the city as an emerging marketplace, right? That it's kind of, I don't know, there's like about 10, 15 years ago, many technology companies realigned their strategic interest from designing software for users to designing cities for citizens in some way, right? And so what does that mean in terms of, yeah, if we think about it as design input, if the city is seen as a product or seen as a marketplace, and so how does that frame the potentials of that city and the potential design possibilities and the potential images for what that city looks like? So I think like that's like a question that I'm always kind of thinking about, right? Like if when the city has become ever more subdivided into different public-private product producing partnerships, and so what kind of I don't know, democratic, not even democratic, like what kind of processes that used to be part of a kind of a public decision making process are now made in a sort of a different way. And then like some of the work we've done, we were looking at actually, you all probably know, it's like that really sort of famous, one of the very first kind of visible smart city projects, the Center for Operations in Rio. It's called CORE. It was built in, I think, it was built in 2014 in the lead up to 2016 Olympic Games in Rio de Janeiro. And it was a sort of a cybernetic new command and control room with IBM, smart city technologies. And it was one of the most visible sort of early smart cities. And it was built actually just to sort of manage the flow of traffic in Rio. And so everyone's kind of like, well, this is a great sort of utility, right? Like this is a great public, and Rio is a very kind of specific urbanism. It has kind of complex topography. It has a complex sort of social economic history. It has complex sort of striations of wealth and inequality. It also has really complex sort of micro weather patterns. And so this new sort of smart city center that IBM built for Rio was there to help manage the flow of traffic. And so that seems to me like, what we were kind of looking at in our project was how something that might seem as benign as traffic engineering somehow gets elevated to urban politics when we start to think about how the street and how all these different events that occur on the street are treated by the algorithm as the same. Whether whether the flow of traffic is interrupted because of some sort of mass political protest, the algorithm sees that as a disruption and classifies it in 4 different tiers of severity to whether it's like a sporting event. And so like a massive crowds, whether it's a sporting event or political protest or sort of quotidian sort of daily life, all of these are kind of flattened onto kind of like the same plane of meaning. And so, this isn't just managing the flow of traffic. It's kind of like potentially anticipating or producing a kind of a possible future where everything falls into an if-else kind of logic. And so, I think like moments like that where kind of like lots of different distributed products are kind of getting implemented to the cities. Kind of what we've been trying to do is figure out and sort of, I don't know, like map some sort of cartography of what that emerging urbanism looks like, right? And so it's hard to kind of, and I think that's what we do really well as architects in some way. We can kind of, you know, we're always sort of able to synthesize many different sort of claims to a possible future. And so that's kind of, you know, the work we've been doing. But it's, yeah, it's always that tension between, you know, exactly what you're saying, like it's a little complicated, but it's like, yeah, like there's a kind of wonderful public utility there. But that public utility is managing the last bit of public space, the street in some way. And it's managing that within these protocols, and that's producing a possible future.
Yeah. So I think that's a really powerful example. Like, I think, you know, also to your point of like traffic is flattened in that space, right? So I think, you know, with any of these paradigms, like there's always this flattening. And the question is like, what is that privilege or not privilege? And that's the kind of, I think that's, you know, very much like the attitude that I take, is that like the ways that things are measured, like generally is flattened in some kinds of ways. Like just the census, right, is another really hugely powerful tool that it hasn't, you know, it's racist, I think. Like there's like 5 categories of ethnicity, and a lot of companies use that to make decisions. Like all the big CPG companies figure out how they want to market things based on the census's way of defining ethnicity. So, you know, that's it. To me, that's like a severe flattening, and it also erases culture. And it says we're going to treat African Americans as one group, and whether they're in Texas or they're in New York. So, but at the same time, the census is a really powerful tool for understanding where people are. And there's many positive uses of it. So I think it's just like, you know, approaching any kind of data measurement with a critical lens and thinking about what's being left out and what nuance is being erased.
Yeah, I want to talk a little bit about that, like the idea of the census as being like a racist collection or use of data. I think that's like an example of a setting of parameters that make the data be deterministic. And I think like part of a way to expand on that, or to expand on actually what Farzin mentioned, with like a disciplinary prerogative to kind of synthesize data, like as architects, to synthesize data from like a whole variety of sets or like different levels of information. I want to ask about the presentation of data, because like as you've demonstrated, Will, like that's something that you're like deep into. So I like to ask the question. So certain types of data, like that which are used for like constructing mobility patterns, for example, like they're a particularly sensitive parameter in terms of like a perception of like data collection and security. So for data, there's clearly a hierarchy in those terms, like what feels like something that is more secure and which would be more protected. So what is the role of data visualization kind of like presenting that, or maybe blunting that intrusion, or like presenting it in a responsible way, I guess?
That's tough. I think you know, it's that particular question is not something that like we've spent a ton of time working on, because you know, mobility patterns are not like the kind of main thing that we've worked on. But yeah, it's interesting. I mean, I guess the question is kind of like, is there a different language that's necessitated by visualizing data that might be sensitive? And like there's something very definitive about a choropleth, right? So a choropleth is like the type of data visualization where you basically see a map on a scale from, you know, the saturation defining kind of where something is concentrated or not. I wonder, I mean, I guess I just to put it back to you, like, do you have something in mind for like a way that type of visualization could be more sensitive than it is, or deal with the intrusion? I
don't have anything. Oh, sorry.
Yeah.
Sorry to interrupt. Yeah, I don't have anything in mind, but it's just like this constant, whenever I see data, like I wonder where the data comes from, because it's such a powerful source. And sometimes it's gathered in ways that, we don't all agree with. That's all it is really.
Yeah.
Can I throw a little something onto that? I think part of that probably emerges from the kind of assumption that data is always institutional. It's kind of sold to us as being geared for governments or being geared towards LLCs or something like that. And those claims lend a kind of air of objectivity to the data, when in reality, data is a highly subjective kind of question. And I think that that's actually I think that's kind of a question of aesthetics, and how I think with COVID mapping and stuff, we're talking about people dying, about people losing loved ones. But what it becomes is, like you were saying, gradients on a map, different hue values on a map. And it's a highly reductionist issue of the data. And I'm not sure what the solution is to that, but I think that it is a problem. And I was wondering, I guess, kind of the question Kevin was asking, how do you guys see that being addressed?
Yeah, I think COVID data I think that's a really good thing to focus on, because it's so, important right now. Like, and the Times has done a number of different COVID visualizations that are really worth spending some time with, and I think are amazing. I think my view is, right now when COVID data is actually actively being suppressed, I err on the side of show everything, because it's actually, really critical, and there's, active suppression by the government of understanding where COVID is in the country. So I very much err on the side of it's important to see, and to give people the resource to know where they should and shouldn't go physically. But I think, that was a big part of the disaggregation project, and that effort was like to try to get to a more accurate understanding of where it was, since it was what we were being given was so meager. And you can see, also, like with the Times, that they've tried a number of different strategies. So, one of the examples is, rather than using a choropleth to show county level COVID data, like they'll do circles, and they'll size circles based on the concentration of COVID in different places. And they convey radically different meanings. Like they have a very, very different perception, which is interesting and also really important. So I think it's a good question.
I'm going to push that a little more. I would think about like a boxing match, even maybe, where at the end of a boxing match, you get all these kind of different stats of what happened in the boxing match, but that entirely misses what the boxing match is. You have no understanding of what actually happened in the boxing match, what the experience of the boxing match was. And I guess what I'm asking is, do you think that data is inherently, the data representation, kind of the data we're talking about, is inherently always going to be reductionist? And maybe that's not a bad thing. Maybe that's a okay thing. Yeah.
Can I? Yeah. I guess, yeah, the question, maybe like one way I'm thinking about the question is, rather than thinking of it as data, thinking about it as potentially like information. How does information inform views and responses, and how is it mobilized, and is a certain way of informing a public, does that abstract away some of the important, some of the kind of important moral or ethical, or embodied components of an event. And so to try to come at it, like I think like maybe like a different COVID image is in my brain, and it was like early COVID, and it was the curve. And you remember when, I don't know, maybe it was probably like around March or something, and the curve was kind of everywhere, and flattening the curve was sort of it was both a kind of it was a chart, right? Like it was sort of mapped to an XY coordinate. It was a kind of I don't know, like an ideological claim. It was a sort of a moral argument, right? Like the argument there was to realign your individual behavior against a collective project, you know, because the idea was to minimize the sort of and spread out the strain on the public health system. And so for me, that was like one of the most kind of, and there were like 50 million, and it became a kind of a symbol, and it became an icon, right? And so this thing kind of operated as, and yeah, like clearly the most suspicious component of that was how it had modeled information, right? Because so it was kind of data visualization as rhetoric, right? But it became a diagram that organized the city in a way that I haven't quite seen many other forms of media do, right? And it somehow collected, and so even there, I think within there, that like when we kind of think about that one, because it's claimed to some sort of the fact that it had to be mapped, it had a sort of a scientific objectivity to it. There was a kind of a authority that came out of the fact that you know, I think it was like a 2010 or something CDC paper where they first produced that sort of idea of flattening the curve. And so I think there's there's a kind of authority that can be mobilized in that way. And so what I would say to you is that, yeah, there is, data is not objective, or information is always presented within a context. Information is always mobilized in certain ways. It's always communicated in certain ways. And so maybe the culture, you know, there's kind of been a cultural sort of fluency that's been sort of developed, definitely also by the New York Times, around like teaching the public how to read stories and read complex events through information visualization. And so, yeah, I think it's not kind of like on the hook, like is data visualization bad? It's more like, what is that culture of abstracting away events into digestible information graphics? What is, you know, does that do the work of allowing you to understand something complex in a way that you might not with, or does it do the work of, yeah, abstracting away or reducing it? And so, yeah, I think it can be used in lots of different ways. But I love that graph, the curve, flattening the curve, because it was everything except for a data visualization, but that's what it claimed to be.
Yeah, totally. No, I think it's, I mean, I think like architectural modeling is a useful like analogy to think about, like where when you're building a model to evaluate or to understand a building or a proposal, you're necessarily getting rid of a lot of detail. Like it's a very constructed thing, and as is any data visualization. So like, you know, in the case of COVID, it can be like, well, you know, where should the ventilators go? And then you want to see a very straightforward visualization of where the caseload is the greatest. But obviously that's very different from saying where is, you know, where are people dying? And that's maybe doesn't need to be visualized in the same way. So it's, you know, it's all constructing the data and visualizing the data involve a lot of choices. And there's a lot that's left out when you do that. But yeah, I think architectural models are very, like, could be useful analogy.
Okay, so we have maybe 10 more minutes. I'm not sure if I want to ask this question. It might take a little while, but I'll say it anyway, and we'll see where we get. like we've been talking about a lot of information that is in some ways really removed from the academic urban design conversation. So I'm like wondering, aside from seeing, big data, we can call it, used in our built cities, like what extent has it figured into, the academy, the schools?
So what kind of information do you think is not inside the academia right now? I'm confused. Give me that question again, a bit more specific. Because I'm kind of like, yeah, like Will's teaching here, and I think the work he's doing is like fantastic, right? And I see sort of these techniques in lots of institutions where I've been at, right? And it feels like urban designers and planners and kind of architects, there's a kind of fluency with thinking through technology networks and thinking through how data-driven decision making is a kind of design paradigm in some way, right? But it's also some form of, I don't know, capability that's starting to be expected, right, of professionals. Is that kind of what you're alluding to?
It was a question out of ignorance. You're answering it right now. Thank you. Yeah.
No, sorry, I didn't mean to. I was not attempting to shame you. You need to go get your data right. No, I kind of say like this, like it was interesting for me because, previously I went to Columbia GSAP and I was teaching there for a while, and I still teach there. And for a while, with kind of the Center for Spatial Research and Laura Kurgan there, who's I think, someone who's been a sort of a leader in terms of thinking about architecture and urban planning and mapping and all the sort of politics of data and all the techniques and developing all that and thinking about that in all sorts of different sort of social justice and urban conflict kind of realms. And then, like there was a kind of a period of time where as always, and as we're doing now with students at Cooper, you're always asking students to question and contest what the definition of architecture is, right, in some way, and to question what the potential forms of practice are, what the sort of references for design or the histories, and to kind of think about, what type of design practice they might want to have at some point in the future, what kind of professional they want to be, what kind of how they want to contribute or to the field or to society in some way. And so I think a lot of our like most critical, sharp, skeptical of I don't know, maybe conventional forms of practice students who came out were kind of, there's like nowhere for them in architecture, right? Because they kind of come out and they're like a wheel or something, and they're just like, well, like, where am I going to work? Like, I'm not like, and so like maybe like you could go work for an SOM and you could kind of do some sort of facade optimization. You could kind of create some tools that moves the sun around and like you could create sort of presentation tools that sort of return yield ever more, and you're just sort of optimizing, accelerating, I don't know, Bjarke-Ingles's kind of diagrams, right? Like maybe you could go do that, but maybe like you're suspicious of that a little bit. And so those students, those graduates, our best graduates, went and worked for like WeWork and for like Sidewalk Labs and went and worked for all these people who, all these kind of companies who before architects had realized the benefit of spatial sort of analytics, and that architects were kind of uniquely positioned to sort of leverage thinking about how environments can be measured, how human behavior and occupancy rates can be visualized, and how the physical sort of substrate of that environment could be kind of changed. And so obviously, WeWork went belly up, and obviously like all these kind of maybe there's like these other sort of ethical quandaries there, but like the way I see your question, and maybe I reformat you, Kevin, it's just like, yeah, like where's the space within our field for students like that, right? Like how do we sort of start to conceive of, how do we kind of take, I don't know, like I would say, and I kind of like, I'm thinking about, Will, your presentation at the lottery, where you're sort of running a seminar where you were partnering up with folks who are kind of in need of data visualization kind of services for and you're thinking about like the sort of public good in some way, right? Like where is that kind of work, right? Like how do you set up a practice that isn't about optimizing WeWork's business model through extractive forms of surveillance of their clients at a, spatially. And so I'm kind of like, yeah, so I think there's a kind of a intelligence that we're building within the academia that is making our students incredibly sharp and effective instruments of the sort of emerging urban urban conditions that are kind of coming out, where there's an alliance between technology companies and new spatial media and thinking about physical space. But we also need to help them land or conceive of practices that, like, so students don't go and become it's like the next version of maybe, yeah, like how do you not become instruments of profit and capital? Or how do you sort of conceive of some of those other sort of, the ethical and sort of the sort of political projects that we might talk about also within academia, and thinking about being custodians of the urban environment, and so I think, yeah, we have to conceive of, it's not so much, we have to conceive of practices and architectural projects potentially in different ways.
Yeah, I think we're super close to the end here. Will, if there's anything you want to add.
Yeah, I mean, I think that was a great answer and really interesting. I mean, I think part of the problem is that, engineers and data scientists are really expensive resources, and software engineers, right? So, in my view, like a lot of the most exciting work that comes from computation in architecture is based on a really deep collaboration between the technologists who are like building it and architects. So like I for example, like Toyo Ito's collaboration with his engineer Sasaki is really inspiring to me, where there was like an iterative design of software and architecture together. And I think that to me is like how data and simulation could be really powerfully integrated into architectural practice, but it's also extremely expensive to to do. So I think that's to the point of, how does that not just become something that the next WeWork is owning? It's a really hard question, and I certainly think like directing those resources towards social justice in the nonprofit world, which have no money to hire data scientists or software engineers, is something that should happen a lot more. And that's kind of what my teaching has been about at Cooper for the past couple of years. So totally agree that that's that's the world that needs it the most and has it the least. But yeah, I think that data isn't to be taken for granted, nor the technologies that visualize and simulate it. And it's a creative, constructive process to make a data set, to analyze it, and to use it as an input. So there's nothing that's given, and every time that it's used, it's a decision to ignore other things and to choose something out.
Yes, thank you. I think this is a great place to end. You've brought us to the doorstep of practice. I think these are questions that I'll be asking myself for, a long time. I'm super thankful for you, Farzin and Will, and then Marin as well for co-moderating. This has been a great experience for me. I've learned a lot. So thank you for that. We'll have another In Conversation lecture later next month. So please join us for that if you enjoyed this. Thank you so much, Will and Farzin.
Yeah, thank you guys. This was great.
Thanks so much.
Talking, great presentations.
Thank you so much.
Thank you.
Thank you.